Find the envelope of x by L plus y by m equals 1, where L and m are parameters which are connected by the equation L by A plus m by b equals 1. Let us call the first equation as equation 1 and the second equation, which is the relation between parameters L and m, as equation 2. When you differentiate equation 1 and equation 2 partially with respect to parameter L, carrying out partial derivative of equation 1 with respect to L, we will get minus x by L square minus y by m square multiplied to dm by dl equals 0. During the partial differentiation process, we will be considering x and y as constants, but from equation 2 it's clear that L depends on m or m depends on L. Hence, when you take partial derivative of second term y by m with respect to L, we will get this term. Taking partial derivative of equation 2 with respect to L, we will get 1 by A plus 1 by B into dm by dl equals 0. We have dm by dl appearing here because from equation 2 it is clear that m can be expressed as a function on L, or m may involve terms containing L. This equation can be rewritten as dm by dl equals minus b by A. Let us call this as equation 4. When you give equation 4 in equation 3, that is when you just replace dm by dl using minus b by A, we have equation 3 rewritten in this way. On simplification, it becomes ax divided by L square equals by divided by m square. You can rewrite ax divided by L square as x by L divided by L by A. Also, by divided by m square can be written as y by m divided by m by b. By applying component or dividend rule, we have these two ratios will be equal to this ratio. We have by equation 1 x by L plus y by m equals 1, and by equation 2 L by A plus m by b equals 1. Thus we have all these three equivalent ratios can be equated to 1. We have this ratio is equivalent to ax by L square and this ratio is equivalent to by m square, and both these expressions can be equated to 1, from which we will get L square equals ax and m square equals by. Let us call these relations as equation 5. When you give these relations in equation 2, which is the equation connecting parameters L and m, we have equation 2 rewritten as root of ax divided by A plus root of by divided by b equals 1. Taking square root on both sides, we will get L equals root of ax. Similarly, taking square root on both sides, here we will get m equals root of by. Equation 2 was L by A plus m by b equals 1, in which we will replace L by root of ax and m by root of by, which will give us this new equation. You can consider A as root A into root A, and root B into root B gives B. Thus we have root of ax divided by root A the whole square equals root x divided by root A, which can be written as x by A the whole raised to 1 by 2. Similarly, we have the second term root of by divided by root b the whole square equals root y divided by root b, which becomes y by b the whole raised to 1 by 2. And thus we have this expression, which is the required equation of envelope independent of parameter L and m.